A warm welcome to everyone. So, in engineering physics, the first unit is mechanics. So, we know everyone know about the mechanics. It's a branch of physics that studies the motion of objects and the forces that cause this motion. It is concerned with the relationship between the motion of an object and the forces acting upon it. So, in this universe, the bodies will either be static or in motion. In elementary mechanics, most of the bodies are assumed to be rigid. But in actual practice, no body is perfectly rigid. When a stationary body is acted upon by some external forces, then the body may start to rotate or may start to move about any point. If the body doesn't move or rotate, then it is said to be in equilibrium. So some basic definition we have to know to understand the mechanics. Now we can see that one. The first basic definition is a angular displacement. So everyone know about the angular displacement. That is the angular displacement. It is the change in the angular position of any object measured in radians. It describes the rotation of an object around a fixed axis. The second one is angular velocity. Angular velocity. It is the rate of change of angular displacement measured in radians per second. It represents the speed of rotation around a fixed axis. Its equation is omega. This angular velocity can be represented with the symbol omega will be equal to d theta by dt. Here, the theta represents the angular displacement which was shown in the figure. The unit of angular acceleration is radian second per minus 1. The next one is angular acceleration. It is the rate of change of angular velocity which was measured in radians per second square. It represents the change in rotational speed around a fixed axis. It can be represented by the symbol alpha will be equal to d omega by dt. Otherwise, according to the angular displacement, we can say the angular acceleration alpha is equal to d square theta by dt square. The unit of angular acceleration is radian second per minus 2. The next one is angular momentum. When we saw the angular velocity, angular acceleration, the next one is angular momentum. It is easy to know that is, it is a measure of an object's tendency to maintain its rotational motion calculated as the product of its moment of inertia and angular velocity. So the angular velocity here it is omega and the moment of inertia can be represented by the symbol I. Now the angular momentum can be mentioned with the symbol capital L will be equal to I omega. So the figure and video shows what is the moment of inertia and what is the angular momentum, how a man can rotate with the water bottle. See the first figure shows the here two figures are showing in the screen. The first one, the man having its hands as very closer one. Here L is equal to I omega. Here the moment of inertia will be lower and angular velocity will be higher. The spinning should be very high. When comparing to the second figure, L will be is equal to I omega. Here, the man stretches its hand and its spinning is slow because the moment of inertia is high when the hand is stretched away and the angular velocity automatically it should be becomes decreases. See the figure, it can be explained by the video. When the man stretches its hands out, what happens? And when the man closes its hand, what happens? The next one, it is inertia. So inertia can be also called as a rotational inertia. Rotational inertia, otherwise it is called as a moment of inertia, is an object resistance to change in its rotational motion depends on its mass distribution and distance from the axis of rotation. Inertia is defined as the tendency of an object to maintain its state of rest or uniform motion along the same direction. Otherwise, inertia is a resisting capacity of an object to alter its state of rest or motion. See the figure? So many different types of mass of the bodies can be rolled from top place to lower place. When it is have a lower mass, it having coming in the first. When you have a higher mass, it will be coming at the last. The next one, dynamics. Now only we are entering into our topic, that is multi-particle dynamics. So before that we have to know about the dynamics. It is a study of motion of bodies under the action of forces, whether it may be in a static or it may be in a rotation. But dynamics represent the study of motion only. The example, the moon affecting the ocean waves is the best example for the external force that act on a body. Next one, coming to the multi-particle dynamics. It is a system of number of particles. It's defined as a study of motion in respect of a group of particles in which the separation between the particle will be very small. That is, the distance between the particle will be negligible. So we know that the mass is the measure of the body's resistance to change the motion, or it is the measure of inertia of the body. It is a scalar quantity and it is constant anywhere. Center of mass shall be understood with the help of the following points. 1. A system consists of many particles with different masses and different positions from the reference point. The mass of the system is equal to the sum of the mass of each particle in the system. Therefore, if the mass of the entire particles of the system is concentrated at a particular point, then that point is called as a center of mass of the system. According to the center of mass of the system, our all the planar system will be working. The system consists of many particles with different position and different masses, because our 9 planets have different masses and different position, but all will be concentrated at a particular point. Then this point is called as a center of mass of the system. So that's all our introduction. So we can stop our slide sharing now and we can see in our next video. Thank you.